Right. Yesterday we started talking about testing of two means. The testing of two means. We had z-tests, we have t-tests with the testing of the two means. Basically, we're doing the exact same thing that we've talked about before in regards to testing. The test value is a little bit different in regards to calculations, how you calculate your test value. You're subtracting your two means from each other, and you're dividing by a little bit different value that it's a little bit more difficult to be able to calculate. It just takes some practice to get used to it. The TI calculators are set up nicely to be able to do that. So it'd be nice if you had one of those, and because those TI calculators follow those orders of operations and make it a lot easier. If I'm a nice person, I will make it so the populations are not equal, the variances are not equal, and that'll make it nicer for your calculations. Then you don't have to go through that big sigma hat calculation. Makes it a little bit better. Questions you have about any of the problems? You had two t-tests, two z-tests. Once again, those formulas you can write on your t-chart to be able to deal with the calculations. Then you don't have to memorize them. All right, we are quickly coming to an end. This is the last. Just get misty-eyed when I talk about that. The last topic that we'll be covering in stats class. Yay! Whoop whoop. Once again, what statistics is gathering data and allowing that data to make predictions for us. Okay, whether it's calculating a mean and the standard deviation, or what we're going to talk about today, what if we had data that was two variable data? How do we deal with two variable data? Well, we can get a two variable relationship, and the relationships could be a bunch of different things. They could be linear, they could be parabolic, they could be exponential. There's infinite number of types of ways of expressing an equation in two variables. We are only going to be dealing with the linear aspect of equations in two variables. But before we go into actual statistical stuff, we have to take a look at how do we determine the equation of a line. So we get to practice some of our algebraic skills. We have our point slope equation of a line that allows us to determine an equation of a line if we know a point, which is x1, y1, and a slope, which is a value of m. Where we have m, x minus x1 is equal to y minus y1, we can substitute in for x1 and y1 and our value for our slope and determine the equation of a line. This is what we did back in algebra. Okay, did it algebra 1, did it algebra 2. Determine the equation of a line. Well, if we're going to have an equation of a line with a slope of 3 that contains an ordered pair 1, 2, we can substitute in for our 3, our slope. We have our x value is 1, so we have x minus 1 is equal to y minus 2. We're just substituting in for our x value, we're substituting in for our y value. We're determining an equation of a line. Distributing our 3 through, we have 3x minus 3 is equal to y minus 2. And get it in the form of y equals mx plus b, we can add our 2 to both sides, so y was equal 3x minus 1. This would allow us to be able to then say, if I had an x value of 5, what would be my y value? If I had an x value of 10, what would be my y value? If I have an x value of 10, my y value would be 29. If I have an x value of -3, my y value would be -10. Well, if we have a slope of a line of 0.24 and we have a point that we have to go through is 4781, determine the equation of the line given that point and that slope. And check your answer with somebody around you. Once again, just reliving our fond memories of algebra and determine the equations of lines. AJ, what do you get for an equation? Y equals 0.24x plus 69.72. Good with that? Yes, no, maybe so. All right. So what we want to be able to do now is, once again, what we've done with statistics throughout is we gather sample data and then we can make predictions about a population. Well, not everything in the world is a one variable statistic. Sometimes you gather two sets of information. So what we want to be able to do is we want to be able to determine a set of data that is in two variables and determine an equation of a line, because if I can determine this equation of a line or parabola or any type of polynomial, I can make a prediction. Given a specific x value, I can predict about y. This is called a least squares equation of a line for a set of data. Okay, when we talk about a least squares, this is a prediction This is a prediction equation for linear data. Given that I have data that comes close to being linear, it may not be exact, which is fine. But if I get a prediction that's close to being linear, I can use a least square prediction or least square equation to predict what the line would be. Well, for us to be able to determine the equation of a line, we need two things. We need a point. Well, the point that the equation, least square equation line will go through is x bar and y bar, the x average and the y average. That is the point that you will go through. And we need to be able to calculate a slope. The slope is calculated by x times y bar minus x bar y bar over sigma x, or the variance of x, the population variance of x. So this x bar y bar is going to be the same as this x bar y bar. And just relax. Our calculator will do a lot of this for us. And we're not going to have to work too hard to get this stuff. Now, this xy bar, this is x times y bar, which means you're multiplying the x values and the y values together and finding the average of the multiplication of these two values. So how we calculate this is we add up all the xy's and divide by the total number of ordered pairs that we have. So we multiply the ordered pairs, the x value and the y value of each of the ordered pairs. We multiply them together, add them up, and divide by the total number of numbers. We also have what is called a scatter plot. It's a graph of ordered pairs of the data that is used to determine a relationship between two variables. This is called a scatter plot. And you may have experienced this in a science class, maybe one of your other mathematics classes, maybe in an algebra class. What we have here is we have the age of a person and the number of sick days that they utilize on a yearly basis. Typically, when you're younger and you have sick leave days, you typically use those as much as possible. Reason why is you sit there and get, I don't feel quite as good this morning, or maybe the weekend might have been a little bit too rough for you, whatever, and you call Monday off being a sick day. You tend to use them a little bit more as you're younger. As you get a little bit older, the number of sick days you utilize tends to decrease. Okay, so as you get a little bit older, you tend to use less sick days, unless you're on a deathbed somewhere. The number of sick days I've used was not very much, except for obviously this past year, a couple months ago. So if we take a look at a scatter plot, we have our age, which is the bottom, our x variable, our sick days, which is our y values. What we need to make sure of is we need to make sure on our graph we cover all of our data values. So I start with 18, I go out to 60. I'm going to count up by tens. 10, 20, 30, 40, 50, 60. Need to make sure I cover my data values, and if I want to, I could divvy these up into halves to give me the fives. The number of sick days, I go from 16 to 2, so I need to make sure I get up to 20. So I can count out by fives if I want. And what a scatter plot is basically each one of these is an ordered pair. Each one of these is an ordered pair. When I'm age 18, I use 16 sick leave days. So at 18, I go up to a value that's close to 16. When I'm 26, I use 12. 39, I use 9. 48, we use 5. 53, we use 6. And 58, we use 2. So basically what we get is we get what is called a scatter plot. I would not be able to draw one line, a straight mark that connects all these points together. But if I take a look, it's fairly linear. I get somewhat sort of a semblance of a line. Where if I wanted to, I could take my straight edge and draw a line through there, which is close to the data values, but not exact. Well, what the least square fit equation would do is it would give us this line, which would allow us to sit there and say, for any age, we can predict out for any age how many sick leave days they would use on a yearly basis. Sometimes your scatter plot will look like an exponential growth or decay. It could look like a parabola. We can determine equations of anything that we want to determine an equation of. So we're going to take a look at this data down here. We're going to determine the equation of that line. Once again, the point will contain our x bar, y bar. We will have a slope, which we can calculate. The correlation coefficient is something that gives you a relationship value that sort of rates your equation. We don't have time to go through the calculations of them, so we're not going to worry about it. But it will pop up on your calculator for the correlation coefficient. It's basically the strength of your equation. Is it a good predictor? Is it a good predictor? You can think of it as a confidence interval. Your correlation coefficient, your R value, if you take the square root of that, will give us our confidence. Our confidence that we will be a pretty good prediction with respect to our equation. So what we're going to do is we're going to go down to the bottom one down here and look at the bottom one. Now, the thing of it is there's a lot of calculations that can come into a factor here. What is nice about your calculator is I can do a lot of these calculations on my calculator. If we go to Stat and Edit, what we now is we have two values that we want to enter in. We have an X value and we have a Y value. So if you have data sitting in there, once again, how we clear that out. Excuse me. We go to second in memory, the plus sign down there, and clear our list. What we want to do is we want to edit. So we want to enter in our data values. In our L1, we want to enter in our X values. In our L2, we want to enter in our Y values. So your L1, enter in your X. 18, 26, 39, 48, 53, and 58. Your Y values, we have 16, 12, 9, 5, 6, and 2. Now your calculator is a very powerful tool. It will do a lot of things for you. It will give you a scatter plot. It will give you a scatter plot. So if I would take a look, let me get my equations out of there. Get your Y1s out of there. And go to your windows. And what we need to make sure we do with our window is make sure we cover our data values. So I can do my data values, my X minimum at 0. I could go up to 60 like I did over here and space it out by 5s. My Y values, I could go from 0 to 20. And we can space that out by 5s. Or if I want to do 10s up there with my X scale like I did, that is fine. We want to turn on a stat plot, and how we can turn on our stat plot, we have two ways of doing that. We could go second and the Y equals, and it gives you stat plots. Let's go stat plot 1, just hit enter, and let's turn it on. If we go to our graph, what we get is that same exact stat plot we just did. The other way of turning on a stat plot, or if you need to turn it off, if you go to Y equals, on your Y equals, you have plot 1, plot 2, plot 3 on top. Plot 1 is highlighted. That means it's turned on. If you want to turn it off, you hit your up arrow, hit enter, and what happens is your stat plot goes away. So if we want to turn it back on, I can go up to plot 1, hit enter, and that turns my stat plot back on. Once again, just different things that your calculator will do for you. But what we want to develop is we want to develop this equation. To develop this equation, we need to find x bar and y bar. Well, we can add up all the x values and divide by the total number of x values. Add up all the y values, divide by the total number of y values. We can find these manually if we wanted to. Or if we go to stat, hit our stat button, and go to calculate. We've only used option number 1, one variable statistic. But now what we have is we have 2 variable statistics. So let's go down to 2 variable statistics. And hit enter. And hit enter one more time. What you will get is we get our x bar, we get our sigma x, but if I keep using my down arrow, I get my y bar, and I get all these values that I want. So what I want you to do is write down what is our x bar, what is our y bar, what is our sigma x, and then at the very bottom, what you get, if you keep scrolling down, you get the sum of your x times y's. Your sum of x, y, which will allow us to calculate our x, y bar. So we can pull this off your calculator. Your X bar was 40.3, your Y bar was 8.3. Your sum of your XY, 16.25. Your sigma X is 14.36. What this will allow us to do is to calculate our XY bar, which is your sum of your XY divided by N. And all you're doing is you're taking 16 times 18 plus 26 times 12 plus 39 times 9 plus 48 times 5 plus 53 times 6 plus 58 times 2. You're just multiplying these two values together and then adding them together. That's your sum of your XY. So we have 1625 divided by 6. Do 70.83. The point that we go through is X bar, Y bar. That's our point. Our slope we have to calculate. We have XY bar minus X bar, Y bar divided by sigma X squared. So throwing in our values, we have 270.83 minus X bar, which is 40.3, times Y bar, which is 8.3, divided by our sigma X, which is 14.36 squared. That's our variance. What do we get our slope to equal? Jenna, what do you come up with? Negative point what? So we can use negative 3.31 as our slope. So now to determine the equation of our line, we have this point that we go through, and here is our slope. So we have x minus x1 equals y minus y1. Well, the point we go through is x bar, y bar. So we have negative 0.31. X minus 40.3 is equal to y minus 8.3. So we can distribute our negative 0.31 through. What I suggest that you do for this test, if you don't have a TI calculator, you better find one because it'll make life a lot easier on yourself. Borrow somebody's. Justin, what do you get for an equation? Plus 29.8.
Or 20.
28.8?
No, just 20.8.
20.8. We good with that? Which allows us now to predict. If a person was age 30, that is our X value. We could put 30 in here and take a negative 0.31 times 30, add 20.8, and that would be the prediction of the number of sick days that person would make. Or if a person's 40 years old, we could put 40 in and predict how many sick leave days that they would utilize. So it allows us to predict out in two variables now rather than just one variable. Even better. If we take a look at our calculator again, and we go to our stat button, and we go to calculate again. As we continue down through the scroll, we have median, we have linear regression, quadratic regression, quadratic, quartic. We have all these regressions. Well, when we determine the equation of a line, this is also called a regression equation. Your calculator will also deal with calculations of this. Let's go to our linear regression and hit enter. Now, the newer fancy calculators will ask for a bunch of different things. It will ask you for maybe what list you're dealing with, okay, which our X variable is L1, our Y variable is L2. If it is not there, you can find your L1 here and your L2 here, hitting your second button and hitting there. It also asks you for a place to store the equation. So what I'm going to do is I'm going to my older school calculators. We have to put, do I need to put a first comma in there? I could go comma L1, comma L2, comma. Now, it will ask you to where do you want to store the equation. You want to store the equation in Y1. Okay, so how do we find Y1 variable? Well, if you hit your second button, oh, not your second, but unhit the second button. Just hit your VARS button over here to the right. VARS. Hit your VARS button. Go to your right arrow, which will give us Y variables, and let's go function. That will give me my Y1. See, I'm not sure if I need a comma in there yet. I'll keep my fingers crossed. Okay, if I hit enter, yep, gave me an error. Doesn't like that first comma. Delete that. So we have L1, comma L2, comma Y1. Now I hit enter. What it gives me is that exact same equation, or close to it. Okay, it's doing exact values with that. But what it also does is if I go to my graph, it gives me my scatter plot, but it also draws the line for me, which shows you, okay, that's the prediction line for what I'm dealing with there. Along with that, this is a KYC moment, we can calculate, and if I look at my Y equals, what I've stored in my y equals is my equation. If I go to second and calculate my value, it asks me what is my x value I want. If I type in the 30, it gives me my y value. So if a person's 30 years old, I expect them to use 11 to 12 sick leave days. If they are 40 years old, they're only going to use about 8 days. If they're 50, prediction is they're going to use 5 or 6 days. Once again, your calculator is a very powerful tool. Okay? There's a lot of things that your calculator will do for you. Okay? You don't have knowledge of it, and as we go through the things, we have the KYC moments where we get to know our calculator a little bit more, and what is doable with our calculator. This takes practice. Okay, it takes practice to be able to go through this. Now, if you go to another class and you're graphing equation you go to graph an equation in another class and you get an error, how you solve that problem is your stat plot is on, and it does not like having your stat plot on as you graph another equation. So what you will have to do if you get an error, if you're trying to graph something, you'll have to just go turn your stat plot off. Once again, my suggestion to you to save yourself on some calculations is make sure you have a calculator that deals with statistics. Find a graphic calculator that will allow you to do that. And like I said, also, you need to, you have to practice going through this stuff. Now, the slope equation, you can also write that on your t-table. So it's sitting there somewhere, how you find the slope. Did I get you guys? All right. How you find the slope, you can also add that to your t-table. You do not have to memorize how you calculate our slope. Questions you have? Okay, once again, what Monday is going to look like is we'll have a review day for two mean testing, hypothesis testing. One of these problems, correlation problems, and what we just did in chapter 7. Tuesday will be the unit test over chapter 7, 8, and 9. We won't be dealing with the correlation coefficient. We don't have another day for that, so that is fine. But some of you, when you do your regression, when you did this regression, they may have gave you an R value. When you did this linear regression, you came up with this, you may see an R value at the bottom of that. You may see an R value at the bottom of that when you find your regression line, your equation. That's a correlation coefficient. As you get closer to 1, the stronger the correlation coefficient. The closer you are to 1 or -1, the better you're going to be with your correlation coefficient or your strength of the equation. You will only be between 1 and -1. You won't go above 1, and you won't go below -1 with the correlation coefficient. And like I said, when you take it's not the square root, take the square of that. When you take the square of that value, and they'll give you an R, some of your calculators will give you an R and an R squared. When you take the square of that, that's your confidence. Your confidence that I have pretty good strength. So you have a 99% there. That's pretty strong with respect to your confidence and your correlation coefficient. Questions you have? QED, you is done. You have finished.